Good evening. It's my pleasure to get an opportunity to talk about the analytics paradigm as such, and particularly about a language called R. And I will also discuss today about the activities that we are involved in CBS about big data analytics domain as well as in the language R. Okay? So to start with, why so much buzz around the business world about big data analytics, and what has led to this scenario where the big data has become one of the prime business model today. I would like to spend just few minutes on that thing before actually getting into the subject matter. As you know, that the internet has gone through several phases of transformation since its inception in 1993 as such. Initially the internet was just a collection of servers, okay, connected by networks. Started with ARPA network in US, later on spread across over the world. But the content sharing was basically from big servers to the clients. Okay, the client's machine could be our desktop. Then with the advent of mobile computing, it could be our laptop. Okay, then the mobile phones came in, but still the internet remained in a model like client-server architecture. Okay, later on, a new paradigm came. Probably some of us could not even notice because it came in so slowly and invaded our day-to-day life so seamlessly that many of us even could not notice that internet walked through a massive change. Okay, what was that change? The change basically is the concept of Web 2.0. What is Web 2.0? Web 2.0 is redefining internet in terms of every participant can be thought of as a server. Like for example, if I have got a laptop, if I have got a mobile phone, if I have got a desktop, and if I am connected to the internet today, then I can be a source of information. Okay? Previous model of internet was that every client was consumer of information, and few servers, big servers like Yahoo, then Microsoft, those servers, Hotmail servers, those servers were the provider of information. Now today, I am equally, as all of us are, a content provider. We can provide information to the world, we can provide image, we can provide videos, right? So now imagine why this is a big change, because there are billions of people in the world, right? So imagine that if every people or every person becomes a source, then what is the volume of information that is generated? I will not say information, I will say data first, because it could be raw data in terms of any format, unstructured data. Some of the data might not be at all valuable in the sense. So it is a raw data floating around. So the problem today, the challenge before us today, before we talk about big data, is the information overload. This is the concept that we have to first understand. That today we are living in a world which is actually challenged by this problem. I will say this is a problem because this is an information overload. Okay? It is not like 3 decades back where getting information was difficult. Okay? Information scarcity was the thing. Now today, you ask for information, you will get overloaded by that. Now extracting meaningful information out of that overload is the crux of the matter today, right? So now relate this, we have got social media, we have got connectivity with every objects, Internet of Things concept have come in, which meant that all objects in the world will be connected with each other. Now each object today can also become a source of information. My refrigerator in my home today can be information provided to the internet, because that is smart enough, it is connected to the internet and it is generating information. It is generating information in the sense what is its content, which content needs to be replenished at what point of time. Okay? So now imagine that why we are facing this problem or this challenge. Because of the fact that we have got numerous sources of information, and each information can be generated by a small device as well as a big device. It doesn't matter the size, it doesn't matter what is the capacity of computing, as long as it has got a processor, as long as it has got a small memory, and as long as it has got a network interface, it is able to pump information into your internet. So now, given the fact that this is something in which you have to live with, that is information overload, how you extract meaningful information, how you make information mining in such a way that the extracted information gives you value. Okay, that's what actually is what the people, the scientist community are looking forward to it. And that has led to the concept of big data analytics, because big data means voluminous data, analytics means extraction and processing so as to arrive at a meaningful conclusion or meaningful decision which can lead to value add. In different domain it has got different connotations. In research community it could be carrying out information analysis which was not possible to be done say 2 decades back, and in case of business it could be extracting meaningful information so that it can assist you in making a good decision for your business, forming your business strategy. Okay, so there are numerous verticals, I am not getting into that thing. So we now understand that why big data has become a buzzword. Now, as you know, this is a very natural phenomenon across the world. It has happened over the history, entire history of human civilization, that whenever something becomes buzzword in the industry or in research community, there are work which goes towards its feasibility and making it possible to implement. So that's why the moment the big data became a reality or became a challenge, immediately the computing community went for developing tools to handle it. Okay, numerous tools, tools like even tools like MATLAB, initial phase. Then came tools like Python, which was old programming language. But one of them who became very predominant, or became probably one of the trendsetter, is a language called R. Okay, and by the time R came into the big data field, the computing community also accepted that open source computing will be the call of the day, right? Because you cannot have a proprietary software dominating such a big business. So that's why R came with a notion of open source computation. Every development that happens, it happens through computing community, which is sharing it on the basis of certain preconditions on a predefined server called CRAN server. That is a separate issue, but I am saying that there is a process of sharing the information in an open source community. So R became a de facto programming language for handling the big data systems. Okay, I am not saying that R is the only programming language, because as you know that in this such a big field there are many other players, but the recent trend is that just because R is supported and encouraged by most of the top computing as well as research communities in the world, R is gradually becoming the most important player in this field. Okay, the recent study says that. So, I mean, big data and R has somewhat become, I will not say big data analytics and R has somewhat become synonymous. With that pretext, I would like to now start into our further discussion, because as with most of the advanced business schools today, as well as the technical schools and universities, we at Calcutta Business School has taken lot of initiatives in contributing as well as educating the computing and research society, communities for this particular work on big data analytics. Okay, there are numerous initiatives we are taking, but I am going to discuss about two programs which actually discusses or rather presents the strength of R as a programming language, particularly with focus to big data analytics. Because R is a very general purpose computing language. It has got its many applications. We will focus on the areas of big data analytics, and we will try to point out that which are the value added components in this particular course. Okay, coming back to the initiatives from CBS that I was discussing, I would like to first present the first program, and the program which is somewhat, you can think of as an initiative to educate the newcomers, okay, in this field. Because that when industry grows in this format, I mean, like the way the big data analytics is going, we need to have huge number of newcomers into this field, because there is a huge demand, large demand. Okay, so for this course, for that purpose, we have introduced a course and for that course, I would like to just elicit the prime objective of this course. The prime objective of this course is that it is not confined only to technologists, neither it is confined only to researchers. Just have a look that it has got an applications which spread across all domains, literally all domains. It spread across consumer behavior, analysis of social media usage, life sciences research, analysis of consumer behavior, okay, healthcare, weather forecasting, and I can name many others, financial analytics, okay, it can be in sports analytics, it can be also in entertainment industry, okay, what kind of music is preferred by what kind of people, what kind of book, what kind of age. So it is somewhat foolish and somewhat futile to try to enumerate what are the applications today. Applications actually probably as many as you can think of. Now why are that also has to be understood. It is rapidly becoming the most widely used tool or software for this purpose, which I have already told. Now just get into the actual content. In fact, if you just have a look that we are planning to launch this course during January 11 to 13, and I would take this opportunity to mention that we have already done one such course in December, or in November 2015, that means in this year, November itself, we have completed this course, one version of this course. The next step is happening in the January 2016, and let me just give you the overview and the methodology as well as content in a very nutshell, so that you understand that what specifically this course is going to offer. Okay, this program covers basically almost all fundamental aspects. It does not assume any prior knowledge, neither in analytics nor in R. Okay, it completely assumes that a participant comes fresh of course has got little bit sense about business. So an MBA student, an engineering student, a researcher working on that, business professional working in other programming language wants to learn R, because he or she finds that big data will be a good opportunity for him or her tomorrow. Okay, so again, there is no end. Any person who is interested in handling and analyzing data would be eligible and find the program suitable. Okay, after completion of the program, the participant actually becomes eligible, or rather becomes capable of handling complicated big data analytics problems. Okay, because by the time he completes or she completes his program, he or she is having enough knowledge and skills to handle the real world business problems, okay, which involves analytics. Because R is something which can do magic. You will see later. Now all the topics will be explained actually by detailed explanation of the theoretical fundamental, of course, because nothing can be just only demonstrated without explaining the theory behind it. But most importantly, they all will be illustrated using case studies, using R hands-on. Okay, so this is the prime feature of this particular course. And let me just briefly outline the course content. It will introduce R as a programming language, then it will introduce R objects, this R being an object-oriented programming. Understanding of the R object is a very important aspect. Then R, fundamental strength of R, let me mention here, is that its ability to analyze statistically the data sets that we have got. So descriptive statistics and tabulation of data is very important aspect of this course. Then we'll try to analyze what are the distributions, data distribution. Then we'll go for hypothesis testing using R language. Hypothesis testing can be done by many other languages, but those who will participate in this course will understand that R provides some sort of a magical simplicity, I call, while handling very complicated problems, because it will not even let the user know that how much complications are happening below, and making it completely transparent to the user and giving them the desired results. Okay, and that's what is important. Not everybody will be the programmers of tomorrow, but there will be a large number of users in big data analysis systems. Okay, so there will be graphical analysis using R, formula notifications and complex statistics. Let me explain this part. So whenever we want to form a model in a system, we want to understand that which is our response variable, we call, that means the variable whose value we are interested in, and which are my predictor variables, that means in so-called mathematical terminology we call them independent variables. Okay, so how we form a model where the response and variable, the category variables or the predictor variables are related with each other in such a way that we can actually predict the response variable's value based on the values of the predictor variable. In simple terms, this framework is known as regression. Okay, but R does not straight away call this regression. R call this as a formula translation. Okay, so we'll see that how to handle regression problem using R. Then we'll also see how to extract components from large data sets for our own analysis. Then we'll go for linear modeling. Okay, linear modeling involving real world data set. We'll see that what kind of data set actually requires linear modeling. And then the program will just make the participants aware about that R is not all about only comments. R also involves writing programs. But this is where the program will come to the end, where it will illustrate the users or the participants how to write R small programs, because writing R programs is not something which can be developed. That skill cannot be developed just by 1 or 2 days time, but it will give enough fundamentals to the participants so that they can later on practice, because those of participants who will be aspiring to make a career in big data analytics, this is a vital requirement. Okay, these are for the big data users. So with this I come to the end of the first program. As I mentioned, I just summarized that this program is meant not for experienced people who are already into art, but the people who are actually the persons who are basically aspiring to enter this field. Okay, so this is all about my first course which we are going to, and let me take some time to discuss about the second program. This program will be a very unique program. This program has got a lot of value add even to the people who are already into our programming language using big data analytics applications. Okay, so this will be not for the fundamental topics. This will be not ideal for people who are new into this field. This will be essentially more suitable for the people who are already into art for at least some time. Okay, now this program we are going to launch the first program of this kind into our business school CBS during January 2022. This will be again a 3-day program targeting again researchers, academicians, professionals who are basically working on art. Okay, who are basically working on art, and the objective of the program, as I mentioned here, basically the objective of the program will be to provide the participants to large number of illustrations in different fields, so as to illustrate that why art is today considered to be so strong and probably the most important candidate or player in big data analytics. The topics have been chosen keeping in mind not only one field. The examples will be varying across different domains. Okay, so let me just show you the first contents and just get you through quickly to the contents, mentioning their importance and their applications. The first point is Bayesian analysis. This particular topic actually talks about predictor and response association in a way so that you can make a very robust forecasting. Because today, business, we are interested in what? We are interested in where we are standing, interested in knowing few things. What are they? Where we are standing, how we are standing vis-a-vis our competitors, what should be our future strategy so that we can only grow. Okay, knowing what are our challenges, what are our potential threats, and how we can better protect us against them. Okay, so all these can be actually handled by a framework called forecasting, because if you can forecast what is going to happen tomorrow, okay, then you can actually get prepared today. Okay, R gives you some of the most fantastic techniques of forecasting, and it not only confined on one particular domain, it is spreading across many domains. So this is the first step towards that. I will get into little bit details later. Classification and discriminant analysis. This is a very classical concept. Okay, classification means, suppose if I have got suppose this is a black box. Okay, I write this as a black box because I do not know what is the content, what are the operations of this box, what is happening inside. But I only know what are the input and what are the output of the box. That's why we call this as a black box. Now input is nothing but our big data system. So a large number of input, large number of data coming in. And output, I am not interested. Here there are huge volume. But here I am sitting and I am interested in only getting 2 two classes of data. One is say yes and one is say no. One is say 1, one is say 0. This labeling I am doing. What is yes and what is no, that I am classifying. What is 1, what is 0, that I am classifying. But what I am interested in doing, that out of this huge stream of information which is coming, I am interested only getting them classified into say 2 branches or 2 categories. Okay? This kind of analysis is called binary discriminant analysis. Okay? Multiple applications. Say I give you one application. Suppose you are the marketing, regional manager, and your boss is the vice president marketing. Okay? There are 5 such regional managers who come forward with their proposals of launching new products. Say there are 6 proposals for launching new products, whereas the vice president marketing has got budget for only 3 products. Okay, launching of products requires cost, so suppose there is a budget only for 3 products, whereas there are proposals for 6. Now how do I take a decision in this case? Which 3 to be chosen and which 3 to be rejected? Now think of, again, as a discriminant analysis, these are your 6 proposals, and which one to be categorized as yes, they will be actually the one to be actually launched, and the ones who are actually chosen to be no, they are not to be going to be launched. So I want a robust model which will allow me or assist me to do that. And this is R is fantastic tool for this kind of work. Only thing that is required is data. Okay, this side huge number of information is required. Anyway, so now there is another, and all these basically are assisting tools. They will allow you to take decision, they will allow you to focus, they will allow you to reduce uncertainty. So risk management also is integrated part of all of them. So decision tree and classification problem, this is also a technique to make classification. Then classification using artificial neural network, classification using support vector machines, clustering, market basket analysis, dimension reduction, text mining and sentiment analysis, and Rin network analysis. Now I will not elaborate each of them, but I will just write one line. I will explain one line for each of them, each of the contents, what are the objective and how the course actually will be conducted. Okay? Now Bayesian analysis, I have already told that it is basically the objective is to predict an unknown binary response of a case from the information that is provided by its predictor or feature variables which are assumed to be categorical. Again, in simple term, it is some sort of a assisting in forecasting. Illustration will be using a case study where we will be using 2201 flight records, the response in which we are interested to see whether or not a flight has been delayed by more than 15 minutes, whether or not. Okay, so this is, we have got a historical record of flights. Now whether a flight has been delayed or not, that records are also there with me. I will be interested in classifying or forecasting that that delay has been more than 15 minutes or not. So this kind of forecasting actually will be done by Bayesian classification. Okay. Now the second one I have already discussed, what is discriminant analysis, to develop a robust and reliable model that can classify data into binary classes. Okay. And illustration will be using a case study with 1000 customer data for analyzing their credit worthiness. So we'll actually take a large number of information about those customers. Each customers have got a lot of variables, lot of information, and we'll develop a model and show that how to rate the customers in terms of their credit worthiness. So you see that 2 applications are completely different. In fact, all the applications have got different connotations. What is decision tree, I have just little bit said. Now let's just have more details. To design decision tree using tree logic for making predictions in a very reliable fashion. Decision trees are non-parametric in nature and very adaptable in representation. Just one point. I mean, regression is never now considered to be a very effective tool of forecasting. Okay, because it is not adaptable, number one. Second time, it is not non-parametric. Okay, if you have to have a non-parametric framework which is adaptable, decision tree is the only, best approach. So R has got that ability. How will you illustrate? We will illustrate using a case study with medical records of 97 male patients for diagnosing prostate cancer. Okay, so how medical diagnosis R has entered. This is the illustration. Real world record, privacy protected, names of the patients are not there. Okay, but they are all real world, so that the information analysis actually is meaningful and with context. Okay, now I have mentioned these two terms, artificial neural network and support vector machines. They are advanced techniques. R has used them in making complex predictions as well as regression. How we will be using them? We will be using around 10 lakh real estate records. Prices, say suppose price per square feet of floor, okay, and that too on different floor, say ground floor, first floor, second floor, on different areas of a particular city. Okay, and then we'll say how to frame up, we'll show how to develop a regression framework so that you can actually predict the real estate price based on the location, based on the floor area, based on the which floor that particular property is. So it's a fantastic demonstration that how R can be actually allowed to get into these kind of fields. Real estate price prediction. Okay. Then this is a topic which is very well known, but R makes a lot of new things here also. To divide a given data set into a given number of clusters using different clustering algorithm, k-means, then hierarchical clusterings and all, using a data set containing information about the type and the quantity of protein intake by people from 25 European countries. Clusters are designed based on their food habits. So what this data set has got, that it has got the food habits of randomly chosen citizens from 25 European countries. Okay, and then have identified that how we can cluster countries based on the food habits. Okay, again a real world data, huge volume. You can see 25 countries, and if I remember, there are hundreds of citizens in each country. Huge volume of data, 250,000 records probably is there. Okay. Then you see association rules and market basket analysis. This is one of the prime area on which the marketing analytics people are working. So here, to mine hidden association between various components of a large data set so as to extract valuable information, our particular focus will be on market basket analysis so that the discovered association rules can be gainfully applied. Now, what is association rule? In a shopping mall, thousands of customers are going every day and purchasing different items. How do I know, or how someone can know that which products are interlinked so that they are having a pattern? When a particular customer purchases X, that particular customer purchases Y also. Now, why I need to know this information? Because if I then put them in the vicinity, X beside Y, then the probability of them getting sold together is almost 1, right? Now, to counter it, just to show that this is a concept, but that concept can be applied in different domains, we are going to show the illustrations using an online music radio. Okay, what is that? In the internet there are a lot of sites where you can actually download and stream, you can listen to stream music. So what kind of music are preferred by what kind of customers, what kind of age group, what kind of region? We want to make an association rule analysis using that. How many things are there? 290,000 records, and we will form mining framework so as to show that what are the rules there. Okay. Then dimension reduction. obviously one of the primary requirement when you have got large number of dimensions, large number of independent variables, the first work that you have to do is that how to reduce, but keeping the information intact. Without losing information, can I throw away some variables out? Yes, we can do. That is called, one of the technique is called principal component analysis, PCA. Okay, and we'll show that how R can be magically simple in carrying out this so-called complicated task of PCA, because other tools, contemporary tools or competitive tools are very notorious in making the things complex. I'm not naming them, but some of them are very notorious about that. But R makes the things very simple. Okay, so using a data set containing information about the type and quantity of protein intake by people again, so that food habit problem, we are now going to make it into a PCA problem. Okay, same problem, now getting into dimension reduction. Text mining and sentiment analysis, I don't have to emphasize the need for it. All of you know what is the current framework in the social media. The text and the unstructured data, of course, needs to be mined so that meaningful information can be gathered. We are going to make two case studies, one for the understanding of the customer's experience about the restaurant, and the other for understanding the political sentiments of a large number of restaurants. So we are illustrating how R can be useful in the political sentiments domain as well. Okay, and this is the last one. We have come to the end. R is network analysis. You know that all of us are, users of Facebook, Twitter, and these kind of social medias. So we can actually borrow the concept of graph theory and get into this domain using a case study with 200 records in a friendship network. Various analysis will be made on the connectivity information. Why I need? Because look at, suppose a person who has got 2,000 friends in Facebook and very active, or in Twitter, suppose 2,000 followers. His view in the internet or in the social media plays a lot of importance, because if he writes something, at least that will be consumed by that many people who are following him. So it is important to identify which are the persons who have got large connectivity in this kind of social network. Okay, R has got an ability to mine in the network and give you those kind of information. So this comes to the end. With this, I come to the end of this content of the course. For any technical queries, you can reach out at this mail address, or any kind of registration related queries, you can reach into this email ID. I am sure that you will get a lot of benefit in participating in this program. Looking forward to see you there. Thanks for your patience here.